Hello everyone, welcome to my channel Coding Together. My name is Vikas Ojha. Today we will see another continuation video of climbing stairs but with tabulation approach. So in my previous video on climbing stairs Leetcode problem, we talked about recursion and then we saw the DP optimization with memoization, and in this video we will talk about another DP approach, that is tabulation, that is bottom up approach. So when we say bottom up approach, it means from smaller sub problems to larger sub problems to larger problems. So we know the smaller sub problem, or we know for smaller value of n, and then if we add those smaller values, we will end up for the larger problems. This is called bottom up approach, that is called tabulation. So how, let's see the same climbing stairs. So if you have not watched before this recursion and DP optimization video on climbing stairs, please go and watch. It's a very useful video on DP and recursion. You will get many benefits of it, and then you can come back to this for the tabulation approach. Now we will see the tabulation approach. So here if we have already seen that, we know that for two steps and one step was our base cases in our recursion and memoization technique. Our base case was n equal to 1 equal to 1, and for n equal to 2 it was 2. These were our base conditions. So we'll start with this only. These will be our sub problems, smaller sub problem. So the base case of the recursion becomes the starting conditions of the tabulation methods generally. So we know that dp of 0 and dp of 1, there is dp of 1 and dp of 2. So dp of 1 is 1 and dp of 2 is 2. We know from the start, because we know our base conditions. To reach step 1 we need one, there is only one way, and to reach step 2 at the top of this two staircase with two steps, it's 2. So we know at the start, from the start. Now what we have to do is for each other upper staircases. So if I draw like this, so this is n, this is 1, this is 2, and this is 3. So if we, for 3, we have to add number of ways I can reach 2 and the number of ways I can reach 1, right? Because I can take one step or two steps. So if I, for 3, it's like number of ways I can reach 3 is equal to number of ways I can reach 2 plus number of ways I can reach 1. So what formula that I can use in our iterative approach or tabulation approach is that for dp of I, what I need is dp of I minus 2 plus dp of I minus 1. We know our subproblems. And we have to calculate the larger subproblem. We have to solve a larger problem. That's it. That is called bottom-up approach. That is called tabulation approach. And we are know our starting conditions, and we have to iterate from the we have to iterate over this relation. And finally, the dp of n will give you the total number of ways we can reach n. Sorry, total number of ways we can reach n. So pretty simple tabulation method. Let's see the code. So for the code you will be easily understand. So it's a simple for base condition, or you can say a precondition, that if n is less than equal to 2, we know that if it is 2, the value will be, the answer will be 2. For 1, answer will be 1. We have initialized our dp. We know that dp of 1 is equal to 1 and dp of 2 is equal to 2 because it's starting with the n is equal to 1. That's why we have taken n plus 1, because it's not a 0 base, it's a 1 based for this problem. So it's 1 more than the length of the number of the stairs. We'll start for I equal to 3 and I less than equal to n, I plus plus. So for dp of I, it will be dp of I minus 1 plus dp of I minus 2. For we know our subproblems. For the smaller subproblems, we will calculate the larger subproblem. Always remember the idea for the tabulation approach. And we'll finally return dp of n, because if we are keep on adding. So for 3, we are taking the sum of ways we can reach n minus 1. For n, we are taking the sum of the number of ways I can reach n minus 1 and number of ways I can reach n minus 2, and we are adding, and we are saying to reach the number of ways I can reach n is summation of these two. So finally, if I will reach the top, so suppose if I this is not n, and if it is top, the final value in the dp will give us the number of ways to reach the top. So pretty simple dp approach tabulation. Now let's see how we can space optimize this solution, this tabulation approach. So if you see this statement, what we see here, we see here that to know the number of ways to reach step I, we need only the number of ways I can reach I minus 1 plus the number of ways I can reach I minus 2. So to calculate dp of I need these two values. Let me draw once again. So if I am at I want the number of ways to reach I only want the number of ways for just below that step and the two steps, the step that is 2 below, right? So can I change this dp1 to previous one? Do I need this dp array? No, actually not. So I can do one thing, that I can remove this and I can say that my previous two, right, this previous two denotes number of ways to reach step 1 and this for step 2. So I can say that take that previous one, right? I can take two variables instead of the dp array. So it will remove the space complexity. It will reduce the space complexity from order of n to order of 1, because we are not using extra space. Now for dpi, so we will take int char, we'll change dpi minus 2 to previous one, and dpi minus 1, sorry, dpi minus 1 to previous one, and dpi minus 1, the other one as previous 2. Okay, the sum of previous one and previous 2. Previous one will be just before the I, and previous 2 will be 2 below the I, right? This is I, and this will be I minus 1, I minus 2. So this will be previous 1, this will be previous 2. Now one more, if I am at I, so I need, as I said, we need previous 1 and previous 2. So suppose if I jump one more step, so if I increment, if I go for I plus 1, then this I will become previous 1, and this previous one will be, the previous 2 will become previous 1, and previous 1 will become I, right? If I go from I to I plus 1, we have to change previous 1 and previous 2. Previous 2 will become previous 1 and previous 1 will become I that we calculated the current. So what we will do, We will store our current previous one will previous two, and will change previous will change previous two as previous one, and previous one equal to cur. And finally at the top, so suppose we reach the top, this we reach the top at I, and we go I plus 1, so this I will be the value of previous one. This I will be the value of previous one that we have to return. Now let's run this program. So test cases are accepted. So we have reduced our space complexity from order of n to order of 1. Hope you like this video, and if you like this video, please share and subscribe. It will keep me motivated to keep on going like this. I already am getting support from you guys, so thanks a ton.